Hello, we are the real-time machine learning-based user authentication via daily activities using wireless signals group, and our advisor is Professor Ying Chen.
Hi, my name is Bhargav.
I'm Rashika.
And I'm Sachin.
So the goal of our project was to recognize human activity using Wi-Fi signals and collecting channel state information. We wanted to implement a real-time system and create user authentication with the device sphere approach. And our ultimate goal was to develop a deep learning-based user authentication to accurately identify each user.
As Rashika stated earlier, we were using CSI to measure these Wi-Fi signals. Specifically, CSI, or channel state information, measures how a Wi-Fi signal is propagated through some medium from a transmitter to a receiver. As shown in the diagram, you can see how someone's positioning or size can change how CSI is being read. Likewise, Wi-Fi signals are separated into several different subsignals or subcarriers by what frequency they're emitted at. And in our case, with 2 transmitters of Wi-Fi signals, 2 receivers for Wi-Fi signals, and 30 subcarriers of frequency that are being read, our setup gives us 120 different streams of CSI data. As Rashika also said earlier, we need to classify this CSI data into different individuals and different individual actions, and doing so with our with our CSI data, which changes based on time. We found that implementing an RNN is the best. An RNN is a recurrent neural network, which is a specific type of neural network that works best for inputs over a period of time. On top of that, we are going to be using an LSTM, which stands for long short-term memory, which has greater functionality for deciding how long of an input over some time you read. With such a large data set, it is not the most effective to take every single bit of CSI information and send it into the RNN all at once. So we use a thing called CSI stream segmentation, which breaks up our CSI stream into smaller groups. We do this by using a thing called a rolling window mean, which just takes the mean value of our CSI data over some 100 data points. And then we see where our CSI value actually intersects with that mean, and use that to classify some sort of 0 point. And that is the beginning or end of some segment that we can then feed into our machine learning model.
So one aspect of our project was a visualization tool, and the purpose of our tool was to graph CSI data in real time. So with this tool, we were able to graph some sample CSI data, and we were able to observe spikes, which meant that the user was performing an activity at that time. And the CSI data that we graphed was for 270 subcarriers. So here we have 2 graphs. One is a graph for sitting and one is a graph for squatting. And we can see multiple spikes in these graphs. And this is indicating that the user is performing an activity at that time.
So over the course of the summer, I conducted 3 experiments: running, walking, and sitting. And each of these experiments had 4 participants. And what we did was we had these participants do the specific activities between the receiver and the transmitter. So here's a little bit of an introduction to the graph. The graphs you'll be seeing in the next slide. Simple sequence is the time sequence for each person in each activity. The amplitude was useful for recognizing the activity and identifying the user based on their movements. And what we discovered was if there was a smaller amplitude, there is less movement, and if there's a larger amplitude, there's more movement. And in the graphs you'll see in the next slide, you'll see some spikes, which are noise and tiny movements. Next slide. So in this, you see 4 people running, and you can see that there are different spikes at different spots, which corresponds to how some people had a different definition of running at a specific point in time. And based on these spikes, we can figure out who a person is based on their identity, where they kind of slow down. So we can classify a person's movement based on these spikes. So as I was saying before, each person had a different amplitude, so they had a different perspective of what running meant to them. And also by collecting enough samples of me and other users running, we can understand a runner's identity based on their amplitude.
Are there any questions?